one more Fourier series. One more program on the Fourier series for the function f of x is equal to a sin x, where the value of x ranges from 0 to pi and it is equal to 0 in the interval pi to 2 pi. Is it okay? As usual, we write f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity of a in cos n x and summation of p and sin x, where the value of n ranges from 1 to infinity, where a naught is octet pi. We know that you observe this. Here the interval ranges from 0 to 2 pi. Therefore, I recall the definition, that is 1 by pi integral 0 to 2 pi of f of x into dx, and Ln is equal to 1 by pi times integral 0 to 2 pi of f of x into cos nx into dx, and Bn is equal to 1 by pi of integral 0 to 2 pi of f of x into sin nx into dx. Okay, now I try to find out the value of a naught. Now, using this formula, it is equal to 1 by pi times integral 0 to 2 pi. Here you observe this. The function is defined as a sin x in the interval 0 pi and it is equal to 0 in the interval pi to 2 pi. Therefore, I split this interval 0 to 2 pi into two parts. One is 0 to pi plus pi to 2 pi. Therefore, this is equal to a sin x into dx plus integral pi to 2 pi of 0 into dx. Okay. Now, you try to evaluate this definite integral now. That is, a naught is equal to 1 by pi times integral 0 to pi of a sin x into dx. A is constant, therefore I take that constant outside the integral sign and I write like this. Okay, I take that a outside the integral sign and this is equal to integration of sin x is minus cos x in between the limits 0 to pi. Integration of this is equal to 0. Okay. In between the limits 0 to pi. Here, whatever may be the value of pi and 2, integration of this is integration of 0 with respect to x, you will get constant in between the limits pi and 2 pi is equal to 0. This is equal to a by pi into minus of, if I am substituting the value of upper limit, this is equal to cos pi, minus into minus will become plus and this is equal to cos 0. Therefore, this is equal to a by pi into minus into cos pi value is minus 1 and cos 0 value is 1, minus into minus is plus. Therefore, 1 plus 1 is equal to 2a by pi. What is this? This is the value of a naught. Is it okay? Now, let us try to find out the value of an using the formula in the same manner. That is, an is equal to 1 by pi. I split this integral into two parts. One is integration from 0 to pi and another one is integration from pi to 2 pi. Therefore, this is equal to a sin x into cos nx into dx. Okay. Plus integration of pi to 2 pi of 0 into. Okay. Therefore, your an is equal to 1 by pi times sin x into cos x. Therefore, I take that a outside the integral sign and I write 0 to pi. This looks like sin a into cos. Sin a into cos t. Sin a into cos t is equal to sin of a plus b plus half sin of a minus b divided by 2. Okay. Therefore, I write this as sin of 1 plus nx plus sin of 1 minus nx divided by 2 into dx. Okay. Since I am using this result, therefore an is equal to a by pi into, I take this 2 outside the integral sign. This is equal to integral 0 to pi of sin of 1 plus nx plus sin of 1 minus nx into dx. Now, when n is equal to 1, a1 is equal to a by 2 divided by 2 pi integral 0 to pi of sin 2x plus sin 1 minus 1 is sin 0. Therefore, this can be written as sin 2x into dx. This is equal to a divided by 2 pi. Integration of sin 2x is, it is minus cos 2x divided by 2 in between the limits 0 to pi. Okay. Now, this is equal to minus a by 2 pi into pi means it is 4 pi into cos 2 pi minus cos 2 pi minus cos 0, it is equal to cos 2 pi value is, you know that it is equal to 1. Therefore, this is minus a by 4 pi into 1 minus 1 which is equal to 0. Therefore, a1 value is equal to 0. For n greater than or equal to 2, an is equal to a divided by 2 pi into integration 0 to pi of sin of 1 plus n into x plus sin of 1 minus nx into dx. This is equal to a divided by 2 pi into, what is integration of sin of 1 plus nx? This is equal to minus of cos of 1 plus nx divided by 1 plus n minus cos of 1 minus nx divided by 1 minus n in between the limits 0 to 1. This is equal to a divided. You observe here minus sign is common for both the terms. I take minus sign as the common factor divided by 2 pi. Now I try to find out the value of cos of 1 plus n pi. Cos of 1 plus n pi means it is cos of a plus b like that. This is cos pi into cos n pi minus of sin pi into sin n pi, okay, divided by 1 plus n plus of I am applying the upper limit again, that is cos pi into cos n pi plus sin pi into sin n pi divided by 1 minus n minus of. Now you observe here, if I am substituting x is equal to 0, it is equal to cos 0. Cos 0 means it is 1. If you want to write, it is cos of 1 plus n into 0 is cos 0 divided by 1 plus n plus cos of 0 divided by 1 minus n. Now observe, I am taking this minus sign as the common factor here, therefore I write the plus term in between. Okay, now I try to simplify the things further. Okay. An is equal to minus a divided by 2 pi into cos pi into cos n pi. This is minus 1 into minus 1 whole power n. Sin pi and sin n pi are 0, therefore this is only this term. Okay, plus minus 1 into minus 1 whole power n divided by 1 minus n minus of 1 over 1 plus n plus of 1 minus n, since sin n pi is equal to 0, which is equal to sin pi and cos 0 is equal to 1 and cos n pi is equal to minus 1 whole power n. Okay. Now I simplify this further. I take minus sign as the common factor outside this, so that it will become a divided by 2 pi into minus 1 whole power n divided by 1 plus n plus of minus 1 whole power n into 1 minus n, and taking minus n as the common factor is 1. Therefore, I write this as 1 plus n plus 1 minus n. Now, I write this as 1 over a divided by 2 pi into. I write this, for these two terms I take minus 1 whole power n as the common factor, 1 plus n into 1 minus n as LCM, so that this will be 1 minus n plus 1 plus n, okay, plus again for these two terms I am taking 1 plus n into 1 minus n as LCM, therefore this is 1 minus n plus 1 plus n. Here minus n plus n is 0, minus n plus n is 0. Therefore, this is equal to a divided by 2 pi into minus 1 whole to the power of n into 1 plus 1 is 2 divided by 1 minus n square plus 2 divided by 1 minus n square. If I take 2 as the common factor for the numerator, it is 2a divided by 2 pi, and if I take 1 minus n square as the common factor, I will get minus 1 whole to the power of n. remains here and it is 1 here. Therefore, your AM is equal to A by pi into minus 1 whole power n plus 1 divided by 1 minus n square. Okay. Now I am trying to calculate the value of Pn now. That is Bn is equal to again the same technique I am using, that is the integral 1 by pi minus pi to pi of a sin x into sin nx into dx plus integral here we are defining in the interval 0 to pi, therefore I need to write this as 0 to pi and pi to 2 pi of a, that is the function is defined as 0 in this interval, therefore I write like this. This is equal to 1 by, I take this a as the common factor, this is a by pi integral 0 to pi sin x into sin x. I am unable to integrate it as it is, therefore I use the technique of, what is that? I use this formula, sin a into sin b is equal to cos of a minus b minus cos of a plus b. Sin a into sin b is equal to cos of a minus b minus cos of a plus b divided by 2. Therefore, I write this as cos of a minus b, that is 1 minus nx minus cos of 1 plus nx divided by 2 into dx. Therefore, I write this as Pn is equal to a divided by 2 pi integral 0 to pi of cos of 1 minus nx minus cos of 1 plus nx into dx. Okay, if I integrate this, I will get, what is integration of cos of 1 minus nx? This is equal to cos to integration only. Therefore, cos integration is sin of 1 minus nx divided by 1 minus n. Or else if you want to calculate the value of, since 1 minus n terms comes means, if I write 1 minus n, if I am substituting n is equal to 1 in the denominator, anything by 0 is going to be infinity. I don't want that. Therefore, I write for n is equal to 1, b1 is equal to a divided by 2 pi integral 0 to pi of, this is equal to cos of 1 minus n means it is 1 minus cos of 1 plus n, and it is 1 plus 1 is cos 2x divided by into dx. Now we will integrate, this is equal to a by 2 pi into integration of 1 with respect to x is x minus minus 1 minus cos 2x. It is integration of cos 2x is equal to what? This is equal to sin 2x divided by 2 in between the limits 0 to pi. Now this is equal to a by 2 pi into that is the value of this. This is equal to pi minus 0 plus minus sin 2 pi. Sin 2 pi value is 0. Similarly, sin 0 value is also 0. This is equal to a pi divided by 2 pi, which is equal to a by, which is equal to a by. Now you find out the value of Pn. Let us try to obtain the Fourier series for the function f of x is equal to 0 in between the limits minus 2 and 0, and it is equal to a for 0 less than or equal to x less than 2. As usual, we consider f of x is equal to a naught by 2 plus summation bn into cos n pi by 2 lx plus bn into sin n pi 2 by x, where the value of n ranges from 1 to n. If you recall the formulas like this in between the limits minus L to L, if you recall that, it is n. If you want to do like that, you can write n pi by L like that. Here, better since 2L is equal to 2. Okay, therefore I write like this. That is, a is equal to minus 2, a plus 2L is equal to 2, which implies that 2L is equal to minus 2 plus 2, it is equal to 4, therefore L is equal to 2. If you recall the general result, you write it. Or else, we are dictating the formula for the Fourier series in the interval minus L comma L, you recall that. Then there is no necessity of writing all these things. If you recall the formulas for the interval in minus L comma L, it is minus 2 to 2 f of x into dx, and a n is equal to 1 by 2 times minus 2 to 2 f of x into cos n pi by 2x, and bn, wherever n is present, I am writing 2 here. You observe that. It is 1 by 2 minus 2 to 2 f of x into cos n pi by 2x, and bn is equal to 1 by 2 integral minus 2 to 2 f of x into sin n pi by 2x. Now I calculate the value of a naught by splitting this integral minus 2 to 2 into 2 parts, as f of x is defined like this. Now I write minus 2 to 0. F of x value in that is 0, therefore I write 0 into dx. Plus integral 0 to 2. In that interval 0 to 2, f of x is defined as a, therefore I write this. Here this term is going to be 0, and the integration of this is a is constant, I write that as it is. Integration of 1 with respect to x is x in between the limit 0 to 2. Now I write 1 by 2 times 2a minus 0, which is equal to 2a by 2, which is equal to a. Therefore the value of a naught is a. Okay, now I try to calculate the value of en, which is equal to 1 by 2 integral minus 2 to 0. I split this interval into 2 parts. One is minus 2 to 0 and another one is 0 to 2. In minus 2 to 0, f of x value is 0, and in 0 to 2, f of x value is a into cos n pi by 2x into dx. I take this 1 by 2. I take this constant a outside the integral sign. Integration of cos n pi by 2x is sin n pi by 2x over n pi by 2 in between the limits 0 to 2. I write a by 2. I take this n pi by 2. 1 over pi by 2 outside the integral sign. So this is 2 over n pi. And if I am substituting x is equal to 2, n pi by 2 divided by 2, 2 get cancelled and sin n pi remains. If I am substituting x is equal to 0, it is sin 0. Sin n pi value is also 0, sin 0 is also 0. Therefore, this is 2 get cancelled with 2 and a over n pi 0 minus 0. 0 into anything is 0. Therefore, your an is 0. Next, I go for the value of Bn. If I consider Bn, it is equal to 1 by 2. Again, I split the integral into two parts, minus 2 to 0. F of x value in that is 0. Therefore, 0 into everything is 0 into dx. Plus, another integration is 0 to 2. F of x value is a in this, a into sin n pi by 2x into dx. So, I write a by 2. Integration, I take this a outside the integral sign. Integration of sin n pi by 2x. Integration of sin n pi by 2 is minus cos n pi by 2 divided by n pi. Now, I write a by 2. I take this minus 1 over n pi by 2 outside this bracket. So, this is minus 2 by n pi. If I am substituting x is equal to 2 here, it is cos n pi. And if I am substituting x is equal to 0, it is cos 0. Cos n pi value is minus 1 whole power n minus 1. I don't want to write minus a in the beginning as usual. Therefore, I take this minus sign inside this bracket and I write a over n pi. Minus into minus is plus. Therefore, it is 1 minus of minus 1 whole power n. Therefore, f of x is equal to a by 2 plus a by y into if n is even, Pn is equal to 0. If n is odd, then f of x is equal to a by 2 plus a by pi into. If I am substituting n as an odd number, this numerator going to be minus 1 that will become 2 over n is an odd number expression of 2n minus 1 into sine of 2n minus 1 times pi by 2x. Okay. Here I simplify the things. A by 2 plus 2a by pi summation n is equal to 1 to infinity and just I am taking this 2 outside the summation sign. 1 over 2n minus 1 into sine of 2n minus 1 times pi x by 2. RHS is the required Fourier series for the given function f of x. Okay, let us try to solve one more problem, that is, let us try to obtain the Fourier series for the function f of x in the interval minus l to l. Now,